Today we're going to talk about slope-intercept form of a line, and it's just a different way of writing the equation of a line. But it really comes from point-slope form. So I want to review what we learned last class, which is point-slope form. And when we know a point on the line and the slope of the line, we can write the equation of the line. So we would just write y equals the slope, parentheses, x, and then sort of the opposite of the x-coordinate, and then the y-coordinate. And a lot of times when we're graphing lines or writing equations of lines, it's really convenient to have the y-intercept and to use the y-intercept. And so in this teeny tiny example, it just says it's nice to use the y-intercept as our point in point-slope form. And I want to show you what happens when we do that. So I've got y equals the slope and then x. And I want you to notice that if we're using the y-intercept, that means the directions are going to say, don't move left or right, just move up or down because it's the y-intercept. So we would have like a +0 here, basically. And then we would have whatever the movement would be to get to our y-intercept. In this case, it would be +2, but I'm going to use the general form, and I'm just going to say plus y1. So when we use the y-intercept, the x-coordinate is always going to be 0. And that allows us to simplify the expression really easily. So if we're not adding anything to x, we don't need the +0, and we don't even need the parentheses. And so it becomes y equals mx plus the y-coordinate of our point, but we want to be really specific that we only get rid of this when we're using the y-intercept. And so we're actually going to use a different letter. Y equals mx plus b. And that's just so we don't get confused. In this case, the b represents the y-coordinate of the y-intercept, and m still represents the slope. And this is called, oops, you couldn't see that. This is called slope-intercept form. But I want to emphasize that it's really just point-slope form using the y-intercept as our point. So I'm going to go through some examples, and I'm going to stick to point-slope form, but you may find that you prefer to just use y equals mx plus b. Sometimes it's a little bit easier. So here's example 1. We're going to write the equation of this line, and I'm going to use the y-intercept as my point. It just makes it easier. So there's my y-intercept, and I'm going to use that point when I write the equation of the line. So I've got y equals the slope, so I should have done the slope first. My slope is 1, 2, 3, up 3, right 1. So the slope equals 3. So I've got y equals m, which in this case is 3, and I need my x. And the directions to get to the point I selected are over 0, so +0, up 1. That's the equation. But I hope you can see that we don't really need the +0, and so we don't really need the parentheses. So it's just y equals 3x plus 1. That's it. And a much easier way to do this would have just been, to say, well, the y-intercept is 1. So I'm going to use 3 for my slope and 1 for the y-intercept. Y equals 3x plus 1. Let's look at example 2. I'm going to use the y-intercept here as my point, and I'm going to write the equation of the line. So first I need to find the slope, and my grid isn't very good here, but hopefully you can see that I'm really just going, oh, this is a mess. It's supposed to be going down 1 and over 1. Okay, so down 1 and over 1, which means my slope is down 1, over 1, rise over run, so my slope is -1. So to write the equation of the line in point-slope form, I'm just going to use -1 as my slope, and then for the directions, I'm not moving left or right because I'm using my y-intercept as my point. And then I'm going up 2, plus 2. And if I simplify that, I just get y equals negative 1x plus 2. That's slope-intercept form. It's a lot simpler. And a shortcut would have been to have found the slope and put that in place of m, and then to use this form, y equals mx plus b, where m is the slope and b is the y-intercept. The y-intercept is a positive 2, and that's why we have a plus 2. Example 3. First thing I want to do when finding the equation of the line is to calculate the slope. So in this case, I'll use those 2 points. I'm going up 1 and right 1. So the slope is 1 over 1, which equals 1. So now I'm going to write the form of the line, or the equation of the line in point-slope form. Y equals 1, and I already know I'm going to use the y-intercept as my point. I already know that I'm not going to go left or right at all to plot that point. So I'm just going to put an x. I could do parentheses and the plus 0, but the plus 0 doesn't do anything. So now I'm going to put my y-intercept, which is negative 2, and that's how to quickly write the equation of the line. Y equals mx plus b, where m is the slope and b is the y-intercept. So it's that simple. Example 4. So this one is important because I don't have the y-intercept graphed. So I could do a couple of things. I could try to kind of figure out where it would cross the y-axis, but I want to show you a different way of doing it. I'm going to first calculate the slope. So there's my little stair step. And we always want to go right, so I can see I'm going right 1, and I'm going down 1, 2, 3. So the slope is rise, which in this case is negative 3, over run. So my slope is going to be negative 3, and I don't see the y-intercept, so it's a little bit difficult for me to use this form. So I'm going to go back up to point-slope form, which always works, and I'm going to select whichever point I want. And to me, that one looks kind of like the easiest one. So I've got y equals m, and I do need parentheses here because I'm not able to use the y-intercept as my point. So I'm going to put my x, and then I need to plot that point. I'm going to have to go right 1. So remember that right 1, when we're using point-slope form, actually means minus 1. And then I need to go up 1, 2, 3, 4, plus 4. That's the point-slope form of a line. But if somebody said, write the equation of that line in slope-intercept form, you might feel a little bit stuck. But all we have to do is simplify this. I can do that because I remember how to use the distributive property. So I'm just going to simplify this equation. I'm going to bring down my y. I'm going to bring down my equal sign. Negative 3 times x is negative 3x. And then negative 3 times negative 1 is positive 3. And then I'm going to bring down the plus 4. And my last step here is just to combine like terms. So I have a plus 3 and a plus 4, and I can combine those together. So bring everything else down. Positive 3 plus 4 is positive 7. That's the equation in slope-intercept form. So basically, all you have to do is write it in point-slope form and simplify. And so what that tells me is that without even being able to see it, I know that the slope is negative 3 and the y-intercept is 7, because in slope-intercept form, this number over here tells you the y-intercept. And so to wrap this up, we are going to take some equations in slope-intercept form and graph them. And there are a couple of ways to do this. One way is to just pretend like it's in point-slope form. That's kind of the long way, but I'll do that on this first example. So I'm going to start by figuring out where's my point. And since there's no number in parentheses, that means I'm not going to go left or right. And a minus 3 outside parentheses means go down 3. Okay, so I'm not moving left or right. I'm going down 3. And that's my starting point. So the faster way to think about it is just to realize that since this is in slope-intercept form and there are no parentheses, this number here, that -3, is the y-intercept. So 1, 2, 3, boom. My slope is 2. That's the same thing as 2 over 1. The top number tells you how far up or down to move, and the bottom number tells you how far to the right. So I'm going to be going up 2 and right 1, up 2 and right 1, and there's our line. Easy. Last example here, y equals -1x plus